Welcome students to your channel, numerical based channel production classes and PSC where logo can talks the physics. Okay, so we are in particular the numerical King series electric field and potential AC Verma solutions we are going through, and this is chapter number 21, question number 31, 32 and 33. And if you were first in that particular class, then go back to the previous one. Here I solved 1 to 30 up to, and then I have solved Gauss's theorem and it is also completed, but still there is a numericals of that is from 33, that is from 33 to for the electric field and potential it is that is from 75. Still there are a large number of numericals and different types of concepts are gathered here, and why I completed 1 to 30 and then go for the next one, that is Gauss's law, because there is I as well as I simultaneously completed the concepts of 11, concepts of 12 and the numericals related with that particular concepts. Okay, so you have to follow all the concepts and the related numericals with that particular King series, the numerical King series, as well as the classic text series that is based on the I Rudolph solution. Okay, and also the related numericals and is the numerical pattern, and I always explain with the along with the concepts. Okay, so students, you have to think the question number 31, 32 and 33, and the concepts, related concepts are the gradient and the simple harmonic motion that we are discuss for that particular class that is related with the concepts of 11th. So let's start with the numericals 31, and I say that you have to take a habit of, first of all, student, write down the questions and think and pause the video and again come back, okay, for the solution. So let's start with question number 31. And students, you can also follow and if your brother sisters are there, then they can follow IIT Foundation course for class 10th, that is for ICS and CSC. Okay, so question number 31, two particles A and B, each having a charge capital Q and placed a distance d apart. Okay, so two particles are there, A and B. So this is particle A and this is particle B, and they separated with a distance of, students, d distance apart, and there are two charges, capital Q here and it is also capital Q here. It is the d distance. Where should a particle Q be placed on the perpendicular bisector of AB so that it experiences maximum force, and what is the magnitude of this maximum force? So students, there are two charges Q and they're separated with a distance d, and you have to place another charge Q on the perpendicular bisector. What is perpendicular bisector? If this is a line, then if you cut and consider a plane, then this plane is called perpendicular bisector, and this is called that equatorial plane. This is called equatorial plane. So again I erase this one, and finally this is Q and this is also Q, and the line joining them, and this is the perpendicular bisector, and I placed a charge of small q here, and this is A and this is B, and since the distance of separation is d, then we can say that this is d by 2 and also this is d by 2. Okay, so two charges A, Q and Q are kept, and the separation is d by 2 and d by 2, and another charge small q is placed, and you have to calculate the net force. You have to calculate the force, maximum force. Why it is called maximum, students? Why it is called maximum? So students think if this is the charge and this is the charge, and if we place the small charge at the midpoint, at the middle here, then this charge can repel this one along this direction, and this charge also repel along this direction, so the net force is 0. So at that point the net force on these small charges is 0, and if we place that particular charge in a large distance from this one, that is we can say that where the field intensity due to this one is 0, that is if we place here, then the electrical influence is 0, and if we place at infinity, then also the electrical influence is 0. So somewhere from 0 to infinity there is a point where if we place this charge, then it experiences a maximum force, and you have to calculate that maximum force. So this charge can repel this one along this direction with a force F. Similarly, this charge can repel this one along this force, and this is also F. And if this is, and we placed this at a distance of x from the midpoint, okay. So two charges are kept and the distance is d by 2, and this is a q charge is placed at a distance x from it, where I think that charges can experience a maximum force. So the force is F equal to this amount, if since this is theta, then this force, and you can take this one as theta, so it will be better for calculation. So this is theta, so this is theta, vertically opposite angle. So since this is F, so this is F cos theta, and this one is F sin theta. Similarly, since this is F, so this one is F sin theta, and students, this one is also F cos theta. So net force equal to 2F. So resultant force or net force equal to 2F cos theta, where F equal to 2 into F equal to we know that 1 by 4 pi epsilon naught, or you can write this value as a constant, proportionality constant, kappa. So 1 by 4 pi epsilon naught, and then small q and the capital Q, that is q1 q2 by r square. What is the value of this one? So this is the hypotenuse, so it is root over of x square plus this one, so this one is d square by 4. So 2 into 1 by 4 pi epsilon q1 q2 by r square. So r square means x square plus d square by 4 into students into cos theta here, into cos theta. So the force is 2 small q capital Q by 4 pi epsilon naught, then x square plus d square by 4 and cos theta. So cos theta equal to base, that is x, by hypotenuse. So this is theta, so this is the perpendicular and this is the base. So x by root over of x square plus d square by 4 and root over of this one. So 2 qx by this value, and we can take it as a constant one. So this one is, if I say this is c, so cx by x square plus d square by 4 whole to the power of, this is 1 and this is root, means students root over of x means x to the power of half. So this is half 1 plus half, 1 plus half, that is 3 by 2, 3 by 2. So x, here it is c, constant means this one is constant, I take as constant. So c equal to, and we can write here as c equal to 2 small q capital Q by 4 pi epsilon naught, 4 pi epsilon, okay. So 2q by 4 pi epsilon naught, this is c, so cx by x square plus d square by 4 whole to the power 3 by 2, okay. So this is a square, d square, and this is 3 by 2. So this is the f. So students, here we see that f is a function of x. F is a function of x means the electrostatic force at that point is 0, and if we move from the midpoint, then electrostatic interaction between the charges on the particular charges decreases, and at when it is at infinity, then the f is again 0. So in between the 0 and infinity, there is somewhere where the electrostatic force is maximum. So what is about maximum and minima concept? Suppose students, this is a graph, and if we calculate the gradient or slope at that point, then you have to take a tangent at that point. And if you want to calculate slope here, then it is also take a tangent. So this is the increasing slope, and this is the decreasing slope. So where the slope is 0, at the peak point, if we take a tangent at that point, then we can say that here, if it is a function of y, then we can say that dy by dx is equal to 0 at that point. Again, students, at that point, we can say that this is the point where also dy by dx equal to 0. So the where the first derivative is 0, where the first order derivative is 0, then we can say that the function reaches at a particular peak level. So here force is the function of x, and if we take a derivative of force, that is dy by dx, and this is equal to 0, then we can get that particular point where the force is maximum, okay. So we can for calculations of the maximum force, you have to take the first derivative of force and then equal to 0. So the next the next step is you have to calculate the maximum force. Where the maximum force is 0. The first question is where the maximum force is 0. Where? So you have to calculate the value of x. First one is x equal to this. This is the first concept. And the second one is what is the magnitude of this. So if we take the first derivative of this one, and students, if you you have knowledge about the derivative, then it is little much tough. So you have to know that particular derivative. So ddx of, we know that ddx of u by v equal to v into differentiation of the first function, then u into differentiation of the second function by v square. This is the concept that I apply on that particular one. So ddx of, this is the dividend rule. So ddx of u by v, when it is given there is a two function, then v du by dx minus u dv by dx by v square. And again I say that if suppose students ddx of x to the power of 5 by x cube is given, then the derivative is v means x cube, and ddx of this one, so this is 5x to the power of 4 minus u means x to the power of 5, and then you have to take this one, so this is 3x square by x cube whole square, that is x to the power of 6. So this one 5x to the power of 7 minus 3x to the power of 7 by x to the power of 6. So this is 2x to the power of 7 by x to the power of 6. So this is 2x. So this is 2x. And again students, you can take ddx of, suppose you can cut this and this one, so it is x square. So x square, and the derivative of x square is 2x to the power of 2 minus 1. So this is 2x. So this one and this one is equal if you take it straight cut, but here it is not possible because u is a function and v is another function which is not divisible by each other. Okay, so you have to take a help of u by v method. So it is a method. So you have to know the particular method, then go through this formula, dividend rule, and take the derivative of this function f equal to cx by x square plus d square by 4 whole to the power 3 by 2, and this is df by dx equal to. So students, c is a constant, so c is a constant, and then this is the v. So v square means x square plus d square by 4, and this is whole to the power of 3 by 2, and the derivative of x, that is ddx of x, means 1 minus then the first function, that is x, and you have to take the derivative of this function. So this is 3 by 2 and 3 by 2, and this is x square plus d square by 4 whole to the power of 3 by 2 minus 1. So this is 3 by 2 minus 1. Students, write down x square plus d square by 4 whole to the power 3 by 2 whole to the power of 3 by 2, and the ddx of x means 1, then x, then ddx of this one, so power is 3 by 2 and x square and 3 by 2 minus 1 into you have to take the derivative, so into and into, here it is into 2 into x divided by. So student, write down the part, and you have to write down 2x here. Okay, so this is, then this is a square, so this is a square, so x square plus d square by 4, and this is 3 by 2 whole square, so this is whole square. Okay students, and I think take it as a step by step. Okay, so write down step by step and realize each and every step, and I think it is not too hard to explain or to realize the numericals. So you have then df by dx equal to 0. Why it is equal to 0? But because at the peak point the slope is 0. Okay, at the steeper one, if it is a steeper one, then the slope first increases and then decreases, so that at that point this is maximum. So when it is a minimum, then again it is a minimum, then there is a peak, and you have to calculate as df by dx is equal to 1. So you have to take the function and as the first derivative 1. So df by dx equal to 1. So this is 0. Since 0 into something, this is 0. So if this is 0, so 0 into something, this is 0, then, and it remains as this part is x square plus d square by 4 whole to the power 3 by 2 whole to the power 3 by 2 minus x into 3 by 2, and this is x square plus d square by 4 whole to the power 3 by 2 minus 1, that is half. 3 by 2 minus 1, that is half into 2x, and 2 cancel this one, 2x. Okay, and this is equal to 0. Since 0 into something equal to 0, and c is also 0, so this one, so x square plus d square by 4 whole to the power 3 by 2, and this equal to 2 cancel, and this is 3x square. Okay, so this is 3x square, and this one is x square plus d square by 4 and whole to the power of half. Okay, so this is half, and this is 3 by 2, that is 3 by 2 means 1 plus half. So this one and this one cancel. This is half and this is, suppose student, this is x into root x and this is x root x, so root x and root x cancel and this one remains. So x square plus d square by 4 means half plus 1, so this one plus this one. So the next step is x square plus b square by 4 and this one equal to 3x square. And since this total is cancelled, total is cancelled with half and this one is remain, so this is equal to this square or x square or d square by 4 equal to 3x square minus x square, that is 2x square. So x equal to x square equal to d square by 8, 4 into 2 8, so x equal to d by root over 8, so this is d by 2 root 2. So this is the answer. This is the answer for the first part. This is the answer for the first part, and the second one is too easy, where the expression in the expression of f you can substitute this value and you can get the next part of it is. So the force is, so this is the first part students. So 31 is, I think of what is the magnitude of the maximum force. So F equal to, if we place this that particular value, then you can get the next part, that is 3.08, and then small q capital Q by 4 pi epsilon naught into d square. So it is the same. You have to substitute the value of x in the previous equation. So students, I think the 31 numerical is completed, and if you I can explain again. So A and B students, and this is a line, and you have to calculate another charge. Here is the charge and this is the charge Q, and you have to place a small charge Q where the force is maximum. This is the main point, where the force is maximum. So if we place the charge particle at that point, then the force is 0 here, and also at infinity force is 0. So somewhere there is a point within that particular line where the force is maximum. So you have to, if I place the charges at here, then this charge repel this one and this charge also repel the one. So the resultant is along this direction, and you have to calculate the resultant 1, then take first derivative and then equal, and then calculate x and then substitute in place of the value of x, and then you get the value of force. Okay, so this is complete, and the students write down the next numerical, that is 31. So the numerical 31, what is about it? 31, two particles A and B, and each carrying a charge capital Q and held fixed with a separation d between them, and a particle C having mass small m and charge Q is kept at the middle point of the line AB, middle point of the line, and if it displaces through a distance x perpendicular to AB, what would be the electric force experienced by it? What would be the electrical force experienced by it? And assume x less d so that the force is proportional to x. Okay, and under what conditions will the particle C execute simple harmonic motion if it is released after such a small displacement? Find the time period of oscillation if these conditions are satisfied. Okay, 31. So students, question number 32, and there are two charges, and this is similar to the 31, question number 31. So this is a charge, this one is capital Q and this one is capital Q, and the separation between them is again d. So this is an equatorial line, and this is d by 2, and this is also d by 2. So a charge Q is kept at that point, and this one is given a force along this direction, and this one also give a force along this direction. So the resultant is, if I take this one is theta, then this is also theta, vertically opposite angle, and this is f, this is f. So this one is f cos theta and f cos theta. So the resultant force F equal to 2f, resultant force equal to 2f cos theta, and this is 2 into f means 1 by 4 pi epsilon naught. So it is taken as kappa, or you can take as 1 by 4 pi epsilon naught. So this one into q by r square, and this one is r square. So this is d square by 4 plus x square, and here x is a very small, x is less of d. So x is very small, this is the main point. So d square by 4 plus x square. So this one is d square by 4 plus of x square, and the cos theta equal to base by hypotenuse. So x by hypotenuse means d square by 4 plus x square. So this is the magnitude of the force, and you can write as 1 by 4 pi epsilon naught. So this is 1 by 2 pi epsilon naught, 2 pi epsilon naught, since 2 and 4 pi epsilon naught cancel this one. So 1 by 4 pi epsilon naught, small q, capital Q, x by d square by 4 plus x square and whole to the power of 3 by 2. So this is this is root under. So 1 plus half, there is 3 by 2. So this is the resultant force, and the answer 1 is completed. Okay, so it's so simple, I think. This is Q, this is Q. So this is the repulsion force, this is the repulsion force. The component of F along this direction is F cos theta, and the component of F along this direction is also F cos theta. So 2F cos theta is the resultant, F cos theta plus F cos theta, and F sin theta. Here it is F sin theta, here it is also F sin theta, and this cancel this one. So the total net force comes from the cos component. So 2F cos theta, and here 2F cos theta by. So this is the resultant. Okay, students. And the next concept is if it is displaced through a distance x perpendicular to AB. So this is A and this is B, and the perpendicular one is along this direction. So this is the perpendicular distance. If it is displaced through a distance x perpendicular to AB, what would be the electric force experienced? So the electric force experienced by this is this one. Next one is, students, assume x less d. If x less d, then show that this force is proportional to x. Okay. So what is about x less of d? X less d means x is very small with respect to this one. So when, students, if x is very small with respect to d, then we can neglect x square. Since x is very small, so students, d, if we take this is a very small, suppose it is 2 lakhs and the x is 1 rupee, then 1 square means it is a very small distance. And if it is a 0.2 whole square, that is 0.04. If it is 2, then 2 square means 4. So when this is very less of this, so a square get a great number, a bigger one, and when x square, then it is a smaller one. Okay, so x square is negligible. So we can write here as when x is less this one, then the force F equal to 1 by 2 pi epsilon naught, and qx by this is negligible, so d square into 2. So this is d cube. So this is d cube by 4. 4 means 2 square. So here, students, d by 2 whole square into 3 by 2 So this and this cancel. So d cube by 8. So d cube by 8, or we can write as d cube by 8, or we can write this one as F equal to 1 by 2 pi epsilon naught, and small q, capital Q, x by d cube, and 8 means 4. So this is 8, and this cancel. So 4 q x by pi epsilon naught d cube, and this is the force experienced by this one if it is a very small, if the charge is displaced through a very small distance, and the answer is so this is 32, and q by 2 pi epsilon naught 32. Yes, this is 2q by 2 pi epsilon naught, and this is 3 by 2. Okay. And when so the second one is assuming x is less d, so that the force is proportional to x. So this is the constant, students. 4 pi epsilon naught d cube, all the constants. So we can write as f is proportional to x, or we can think that force equal to mass into acceleration, and this is proportional to x, or we can say that acceleration is also proportional to x. So when acceleration is proportional to the displacement, this is the concept of SHM. So what is about SHM? When acceleration of the body, if a pendulum is given, if I take a pendulum or a spring, then if this is the oscillation takes place, then we can say that when we displaces a longer, then it takes a greater acceleration. If we displaces this one a greater value, then it can oscillate with a greater acceleration. So when acceleration, we can say that the force or acceleration is proportional to the displacement and acts towards the mean position. So F is proportional to x means mass into acceleration is proportional to x, or acceleration is proportional to x. So when acceleration is proportional to x, then we can say that the charged particle oscillates. So this charged particle, when this is very small distance, then the charged particle oscillate along the equatorial region, along the equatorial plane. And you have to calculate what is the value of the time period. So what is the time taken to oscillate the charged particle, time taken to complete one oscillation. So this is the force, and force equal to mass into acceleration. So this is the force equal to force equal to mass into acceleration, and this is equal to 4 by pi epsilon naught qx by dq. So acceleration equal to 4 by m pi epsilon naught q by dq into x. So acceleration equal to, students, we know that this is omega square x from the concept of SHM, and this is always towards the mean position. Here the oscillation takes place, so this is omega square, and here omega square is equal to 4 by m pi epsilon naught q by d cube, and this is x. Sorry, omega square is this one. So omega equal to 2 pi by capital T. So omega equal to 2 pi by capital T, and this leads to this value 4 by m pi epsilon naught into small q capital Q by d cube. So the time period is t equal to 2 pi, and the root over of, you have to take a root over, sorry, this is omega equal to this one, so this is a root of this one. Omega equal to 2 pi by t equal to root over of this one, so 2 pi into root over of, so 4 m pi epsilon naught q by sorry omega. So you have to take a reciprocal of this one. So t equal to 2 pi is the cross multiplication, and m pi epsilon naught d cube by 4 q cube. So this is the time period, expression for time period, and if you take into account this within the root, then this is 2 when comes into this root, then it is 4, and pi is pi square. So this is 4 and 4 cancel this one, so the time period equal to m and then pi and then pi square, so this is pi cube, and epsilon naught, and this is d cube by 4 and 4 cancel this one, so small q and capital Q, and the root over, you have to take a root over. So this is the time period, and I check the answer. So pi cube epsilon naught md cube by q. So here it is a small, I make some mistake here because there is a value. No, this is the answer, pi d cube. Yes, this is the answer. This is the answer, 32. Okay, yes, this is 32, and the answer is pi m pi cube epsilon naught d cube q cube to the power of half. Okay, so students, the concepts, all the concepts is related with the SHM. So you have to clear your concepts related with SHMs, and the next one is, I think this is SHM and the gradient concept. So you have to clear the concepts of differentiation, calculus. So you have to clear the concepts of calculus. And the next one is, students, next numerical is 33. So write down 33 and repeat the previous problem. If the particle C is displaced for a distance x along AB, then repeat the problem. So you have to take into account what is the force experienced by this one, and also calculate the time period of oscillation takes place. So this is a capital Q1, and this is also capital Q1, and the separation between the charges, and the separation between the charges is given is d. So this is d by 2, and this is also d by 2, and this is the midpoint, and here it is given a small q charge. And for that, question number 33, students, you have to displace this one along this direction. So suppose here, and the distance is x, this one is x, so this distance becomes d by 2 plus x, and this distance becomes d by 2 minus x. So the force exerted by this charge along this direction is, this one is F equal to, suppose it is F equal to kappa means 1 by 4 pi epsilon naught into small q capital Q by this distance square. So d by 2 minus x whole square, and this one, so it is A and this is B if I take, so this is FB, and it is FA equal to kappa QQ by d by 2 plus of x square. And which one is greater, students? So this is the small distance and this is a greater, student. So this force is maximum. So FB is greater than of FA. So the resultant one is FB minus of FA. Okay. So FB minus FA, and here there is some related constant are there. So you have to take into account a common as kappa QQ, and the FB is 1 by d by 2 minus x, and this is a square, minus 1 by d by 2 plus x, and this is also a square. So this is kappa small q capital Q, and the LCM is, there is plus and minus, a plus b into a minus b, so this is a square minus b square, and again a square minus b square, so this is whole square. A plus b, a minus b, and there is a 2, so a plus b, a minus b, a square minus b square, and this is whole square, and this cancel one, so d by 2 minus plus x whole square minus here d by 2 minus x whole square. So a plus b whole square minus a minus b whole square for AB. So this is a formula. We know that this is a formula. So the force one is kappa small q capital Q, and this is 4AB. AB means d by 2 into x, 4AB, and this one is d by 2 whole square minus x square, and this is also a square. So this is the force experienced by this one. And if I take into account that x is less d, if I take into account that x is less d, then you have to neglect this one. So the force becomes, so the force is, then the force is kappa into small q capital Q, or this one is 2dx. So 2 to cancel, and here it is a d. So 2dx by when x square is negligible, then d by 2 whole square and then square. So d cube. So d to the power 4 by square is so 2 to the 4 and 4 16. So kappa here is 1 by 4 pi epsilon naught, and this is 1 by 4 pi epsilon naught into 16, and then small q capital Q 2dx by d to the power of 4. So d and d cancel this one, so d and d cancel this one, and this is cube. Okay, so d cube and 4, and this is 2, so 16, here is 4 and 4, so So 4 to the 8 q, and this is x, and this is x, here it is the x, and this is pi epsilon naught into dq, pi epsilon naught. This is the force, so force is proportional to x. Okay, so force is proportional to x means this is also SHM and this is also SHM. So you have to calculate a time period 1. So the time period is force equal to mass into acceleration. So force equal to mass into acceleration. So acceleration equal to 8q capital Q by pi epsilon naught into dq into small m, and this is x. So this one is omega square. So omega square equal to 8 small q capital Q by pi epsilon naught d cube into small m. Okay, this one pi epsilon naught d cube, and this is omega square. So omega equal to root over of this one, or time period equal to 2 pi, and take as this one is pi epsilon naught d cube into small m by 8q cube. When this one is comes into this one, so this is root over of 2 to the 4 into pi, this pi cube epsilon naught d cube small m by 8q capital Q. So this is 4 to the 8 and the pi cube epsilon naught d cube m, and I check this one. So this is a root over of 1 pi cube epsilon naught m d cube by 2, and this is the answer, students. So this is time period. So the expression for time period is this, and this is final answer. Okay. So students, I think that you have clear and your concepts from 30, 130, 133 on all the numericals are related with the gradient and the SHMs, and most of all the Coulomb's law. Okay, and the related concepts is component division. So if it is not clear, the component division, Coulomb's law, and the gradient and the concepts, last one is SHM, then clear your concepts and see this again, and then I think it will be clear for you. Okay, so thank you, and continue your study last of all, and stay with me. And hopefully, if you think that this is wow, the concepts is very good, then you have to share with this channel, and I think you like it. Okay, so thank you.